Good day. Welcome to HVAC 342. This lecture is going to be on variable air volume systems for Lab 8. Again, in your lab, you will have a sheet just talks about the air handling units and the VAV system for it. Before we create that, I want to go in and look and see what Carrier has in their help screen for this. This happened to be the VRF, so I'm going to go back and I'm going to go into, in this case here, we're going to put a chiller and a boiler system onto an air handling unit. It'll be a rooftop unit. It's okay. And then we're going to go ahead and we have to put a small boiler system in with 2 boilers, and we're going to put in 1 air-cooled chiller. So we're going to start off with this, but just talking about the air handling side. So I'm going to pick a chilled water air handling unit and go to VAV. What VAV stands for is variable air volume. Remember, we also did a VVT system for this lab, and that's variable volume, variable temperature. This is just variable air volume. And the way VAV systems operate are pretty straightforward. They have a fan system that produces typically a very constant temperature between 55 and 57 degrees. The reason they do that in larger buildings or in different buildings, they always are predicated that they have a cooling load somewhere. So what they'll do is they'll put out 55, 57. It could get up into the 60 degrees if they can do a reset schedule with newer control systems out there. And if there's not a large cooling load, we might not need 55 degree discharge air. We might be able to go a little bit higher. When we go a little bit higher, what tends to happen is we get more ventilation, more airflow through the building, or I should say not ventilation, but air flowing through the building. And it tends to work a little bit better for the people inside the building. But let's talk about this a little bit. I'm going to scroll down here and I'm going to stop right here. Now, again, for our building here, we're going to have a new rooftop variable air volume unit with chilled water coil and hot water coil. So it'll be a chilled water coil here, and here will be hot water. We're going to have an economizer with it. Check for a heat wheel. It's the same way that we've done these before. So what happens here is this fan is going to be producing colder air, 55 degrees, sometimes a little bit warmer than that, but usually not too much. And it goes through the supply ductwork and it comes into a variable air volume box. The zoning, which we've established an assignment for, we'll put in the same number of zones that we used in for the VVT or the VRF system. So the zoning will remain the same. But what I want you to do is I want you to put on the perimeter zones of the building a thing called a parallel fan powered box. A parallel fan powered VAV box. And on the interior zone, we're just going to go with a VAV box with a reheat coil. So 2 different ways with that. Now, the theory behind these and how they work is relatively simple. These units have a minimum damper stop on them, or they do it by CFM. So they'll go to if the space is not calling for cooling, it will go to a minimum airflow for ventilation. If it's not on a call for heating or cooling, it'll just be on ventilation. You'll get minimum airflow through it. When the unit decides to go into heating mode, there's 2 things that happen. First of all, this damper is going to maintain at minimum position to bring in fresh air because we're dumping in cool air. So the more air I would let in, if I'm going for heating, I'd have to overcome the cold air to get our space warm. So there's 2 stages of heat. Now typically what happens is the first stage of heat is the fan, second stage of the heat is the reheat coil. So when this fan comes on, what it does is it's going to pull some air out of the plenum because these boxes are physically located above the plenum. So it's going to pull some of that air out of the plenum and circulate it into the space. Keep just recirculating like this. If that will not heat the space, then we'll index our heating coil. And our heating coil here is going to have hot water. So I'm going to have a hot water coil in the unit. I'm going to have a hot water coil on each one of the fan powered boxes. I'm going to have a hot water coil on the internal zone. And that space 107, the mechanical room, instead of leaving that with an electric heat, we're going to put a hot water heater in that also. So again, the purpose of these is this variable air volume unit. The temperature is constant. These dampers are all moving. So we're going to have somewhere around, 8 to 12 zones. As we go ahead, each one of those zones, these dampers will be moving to different positions. As those positions change, we're going to be the pressure in the primary ductwork is going to change. Where this gets the variable, the VAV part variable, is we're monitoring this pressure here, and we change the speed of the fan, typically with a variable frequency drive, and it will speed the fan up and down to maintain pressure in the ductwork. So we'll have either, in the wintertime, we'll use the economizer for free cooling. So in other words, we'll bring in outside air to cool the building. By the way, when we do that, that's really healthy for the building. It's expensive because we have to go ahead and treat that cold air, warm it up a little bit. But it really, when we're using outside air for cooling, we're really ventilating the building, so it works out really well. We typically have less issues with building stuffiness in the wintertime than in the summertime. So, we're going to go ahead and the free cooling is going to go on. We're going to be moving those dampers in order to maintain a 55 degrees or 57 degree discharge. Now, what happens when it's 10 below outside? When that happens, I'm bringing in really cold air. I can't put in, and I've got to bring in a minimum amount of air for ventilation for all of these minimum positions. So I have to ventilate this space no matter what, or the building no matter what. And I might have to bring in real cold air outside and discharge it down the ductwork. These heating coils are not designed for cold air. So what we're going to have to do is warm that air up a little bit to get around 55, 57 degrees, maybe 60 degrees. And we do that with this preheat coil. So what goes on in the wintertime is sometimes we'll see this coil be indexed. The reason that coil would be indexed or opened up, the valve starts moving on that, is if the entering air, is real cold, and really what it controls to is the leaving air. What's going to happen is we want to maintain a minimum temperature here. Conversely, in the summertime, we're trying to cool this down to 55 degrees. So we're going to be in the summer, we'll be at minimum outside air, the smallest amount we can bring in. Typically, there's an airflow station on there that actually measures airflow, and we document how much air is coming into the building. And then we cool that down to 55, 57 degrees. So theoretically, when we look at this system, variable volume, but the temperature pretty much stays the same. With that VVT system we talked about earlier, essentially this unit is changing over into heating mode or cooling mode, and it keeps doing that. With a VAV, we're designed to maintain cool temperature coming into it. So let's create a system. Before that, you'll find all the information for this here. You can see in here we've got, right off the bat, I talk about when we're in free cooling or economization, we want to heat the air to 56 degrees. And we've got 2.5 inches of water column on the fan. So what we're going to do is I'm going to go in here and make one of these up. So I'm going to go right to the VVT system. I'm going to right click and duplicate it. And I'm going to rename this Med Center AHU system. And I'm going to pick here a chilled water air handling unit. I'm going to pick variable air volume, and I'm going to leave my 3 zones in. Here, I'll make this a little bit larger here. Guess I can't. So from there, we'll just keep going. System components. We're going to have an economizer on it. We're going to put in integrated enthalpy. If it has a vent wheel on it, or enthalpy wheel, we'll put that on here, or a heat wheel. Notice we have a preheating coil and we have a cooling coil. The preheating coil We're going to use hot water. I think I had this set to 56 degrees. And the coil position is, now the mixing point is where the outside air and the return air come together. If we looked at this, our mixing point is right here. This preheat coil, sometimes they can put them in this ductwork ahead of this. Right now we're downstream of the mixing point is what I wanted to get to with that. Okay, let's keep going here. Cooling coil, we have to put in what our discharge temperature is, and because we said this was going to be a chilled water coil on it, comes up with that. We have to put some fan energy in. Well, what did that have over here? Somewhere around 2.5 inches. And we're also going to put a duct system in, return air plenum. We're going to put in 33%, and we're going to put in, with that, I think we're pretty well set. Okay, zoning components. We're going to go through, we have our 3 zones again. They should already all be created with the same zones as we did before. Thermostats, again, we're going to have to change these. And then we're going to go ahead and figure out which zone had the exhaust in it and put the exhaust amount in it with the amount of current draw for the exhaust fan. And I went ahead and grabbed a thermostat again. Now this is where it gets kind of fun. What we're going to do is, for this case here, let's say that zone 3 that we made up is going to have a VAV box with reheat, and the other ones are fan powered boxes. What you're going to have to do, you can do this a couple of ways. I can go ahead and say all zones are going to be parallel fan powered boxes with reheat. I have to put the consumption of the fan, which is in right down here at 0.5. I'm going to put in air changes per hour, and I believe I left this at 1.5 again. And we're going to say hot water is what we're going to use for it. But now we've made all zones the same. So let's say zone 3. So I'm going to uncheck this. Zone 1, zone 2. If zone 3 has VAV box with reheat, we could just change that one there. Don't forget to put your design supply temperature in here too. All right, sizing data. We have safety factor in here again. And on our equipment side here, the only thing we have in here is a changeover controller. And with this here, we don't need to use this. This is if we only had, this air handling unit is going to have hot water piping to it and chilled water piping. Some of the buildings out there, they only ran one set of pipes, and they either put hot water through it or chilled water through it. And there's a changeover, and something has to trigger it. It's typically outside air. So we're not going to use that at all. We're not going to use this for it. So I'm going to hit OK here, and I'm going to hit OK again, and now we've got that VAV unit. Now if you think about it, how come I didn't have, with these 2 units that I made, I had to go ahead in here and I had to actually say what efficiencies they are. Keep in mind that with a VAV system, we're going to have to make a couple of plants here, a chilled water plant and a hot water plant, and that's where the efficiencies are going to be set. Now in addition, while we're here, we might as well make up another unit heater, because this unit heater, I'm going to duplicate it, uses electric, and we probably need to go ahead and make one that says hot water. And in here, we're going to come in and we're going to say central heat here, and we're going to make this hot water. And when I do that, I should have another unit show up, and we're pretty well set. So by watching the 3 videos so far, we created a VAV system, we created a VRF system, and we created a VVT system. Thank you. Have a great day.